Hello, my name is Mari Jensen. Welcome to this presentation of the PicoBlaze's instruction set and application. These are the learning outcomes. After watching this video, you will be able to describe the PicoBlaze's programming model in short terms, name the instructions used in the PicoBlaze and describe their operations, and name some of the applications of the PicoBlaze. This is an overview of the programming model, which is also called the instruction set architecture. As mentioned in the previous presentation, there are 16 8-bit registers, a 64-byte data RAM, the 3 flags of carry, 0 and interrupt, the program counter, and the top of stack pointer. When an instruction is executed, the contents of these are modified explicitly or implicitly. The PicoBlaze has 57 instructions, which are organized into 7 categories, according to what operations they perform. There are 6 logical instructions in total, which are the usual suspects of AND, OR, and exclusive OR operations. There are 8 arithmetic instructions in total, again the usual suspects of add and subtract, but with or without a carry flag. The compare and test instructions, content of register is kept intact. The compare instruction performs a subtraction operation, whereas a test instruction performs an AND operation. The results of these operations are used to set the carry and 0 flags. As we can see in this diagram, there are 4 shift left and 4 shift right instructions, and 2 rotate instructions here and here. Up here, it shifts all registers to the left and inputs a 0 as the least significant bit. Here it does the same, but inputs the 1 instead. In this next one, the last register also becomes the least significant bit. And in this 4th one, the carry flag is shifted into the least significant bit. The rotate left instructions does what it says on the tin, and shifts all the registers 1 place to the left and inserts the most significant bit in as the least significant bit. On this corresponding side, we see the same thing happening, though in the opposite direction. The data movement instructions. These are used to move data between 2 registers, or a register and a RAM, or a register and an input-output port. The program flow control instruction. The program counter points to the address of the next instruction. By default, this counter is implicitly set to increase by 1. The following instructions may load a value explicitly into the program counter and thus change the program flow. Jump instruction loads a new address and makes a program counter branch out of its current flow and into this new address. From there it continues on as normal. The call functions work in the same way as a jump instruction. In addition, however, it also saves the current value of the program counter on top of the stack, so that a return instruction may be used to bring it back to this point. Interrupt related instructions. There are 2 return from interrupt and 2 enable/disable interrupt instructions. When an interrupt flag I is initiated, then the current instruction is completed. The address of the new instruction is saved on top of the call return stack. Carry and 0 flags are preserved and an interrupt flag is disabled. The program counter is loaded with 3FF, which is the starting address of the interrupt service routine. Interrupt handling is explained in more detail in a later presentation. The PicoBlaze microcontroller can only perform one predefined real-time operation at a time. It may need many instructions to perform the same task and thus require much more time than its counterpart, the customized FSMD. So why use the PicoBlaze? It is 100% embedded core, which can be included several times in any Spartan 6, Vertex 6 or 7 series design. It requires only 26 logic slices. There is no need to plan ahead if you should or should not use it, as it can be inserted into any program at any time. Skill level required from the programmer is anything in between a skilled hardware programmer to a novice. You only need a base knowledge of HDL coding and development. As to why one should embed a microcontroller into hardware, this is to make some of the parallel hardware more sequential in its execution. It is also used to time-share hardware resources when several slow tasks need to be performed. Application of PicoBlaze. The following are some examples of the applications which the PicoBlaze is well equipped for. A LED flasher, a switch monitor, a UART interface and simple command state or status terminal, an LCD character module display interface and control, a calculator, a system monitoring, for example temperature monitor and a fan control, the mouse or keyboard interface, or as a power supply monitoring and control. As a final note, I wish to refer to the following link to the user guide of the new KCPSM6 module. This includes a short guide as to how to get started building and implementing the PicoBlaze microprocessor. Thank you for your attention.